Before we get into the last thing today, we're going to be finding or knowing how to multiply complex conjugates, which we're going to be using those to find complex zeros or finding a polynomial with complex zeros. So let's go ahead and try this one. So the idea is we have to distribute this. So we're going to take first x times x, which is x squared. Then we have to take x times this, which is minus this 4 plus I times x. And then we have to do this times this, which is minus, that x didn't go in. So minus that 4 minus I times this x. And then we have to do the last one. Let's do that in this color. So this times this, which is negative and a negative, which gives me a positive 4 minus I times 4 plus I. So we'll have to do all of this, which is kind of gross, but not that bad. So this is x squared minus, if you do that, it'd be 4x minus ix. Again, this x goes into both of those, and both of them will be negative, because we're subtracting both the 4 and the I and put x to both. And then the same thing here, we'd be subtracting 4 and x and then adding ix. So if we do that, so it'd be minus 4x and then plus ix. And then when we distribute this one out, because they are complex conjugates of each other, what happens is we end up getting positive 16 and then minus I squared, because the the plus 4i and the minus 4i will cancel out. Now, just as a reminder, we know that this I squared, if you forgot, is negative 1. So recall that I squared is equal to negative 1. That is something you need to remember. So therefore, this turns into negative 1, which is just a positive 1 here. So if I simplify this, the negative ix, the positive ix go away. We can combine this with this, and then we can combine this with this. So we get x squared, the minus 8x, and then the plus 17 for this final answer here. So why would we do that? Well, we're going to find the actual polynomial. So we're going to go backwards again, like we did before, to find our answer. So remember when we had these are zeros, remember we'll say x is negative 2, x is negative 3i, and we have to go backwards. But because this one is here, this one always comes in a conjugate pair. So this always, so anytime you have a square root or an I, anything that's complex, anything that has a square root or a I in it will always have a conjugate pair. And what that means is, what is the conjugate of negative 3i? Well, the conjugate of negative 3i is positive 3i. So we'll think about, well, what's the opposite of this? Because this is 0 minus 3i, and 0 plus 3i would be the two conjugate pairs. So those are my zeros. So once we do that, we can simplify this as x plus 2 is 0, x plus 3i is 0, and x minus 3i is equal to 0. Then remember, we're going to combine all of these into the one polynomial. So combine it because we're doing f of x. So our function f of x is equal to x plus 2 times x plus 3i, and then times x minus 3i. Now we just have to distribute it all out. And choosing which to distribute first is the important part. So this and this, because they're complex conjugates, it's really easy to multiply out. So when we do that, we leave this first x plus 2 all alone, because when you multiply numbers, you only do 2 numbers at a time. You can't multiply 3 all at the same time. It doesn't make sense. You have to do 1 at a time. So in this case, we get the quantity x squared, and then we get minus 3ix, and then plus 3ix, and then minus 9i squared. Which, this is nice, again, complex conjugates, those will undo each other. Remember, this turns into a positive 9, as we did in chapter 0, because I squared is negative 1. Therefore, we get that f of x is equal to the quantity of x plus 2 times x squared, and then plus 9. Now we have to distribute that out. So now this next one we distribute to this, which f of x is going to be that x to the third. When we do this one to this one, it is a positive 9x. This to here is positive 2x to the second, and here to here is plus 18. Now we should put this in our order and combine like terms if possible. Well, x to the third is highest, then plus 2x to the second, and then plus 9x, and then plus 18 in descending order of the highest degree. And that would be my final answer for f of x. So our last example is something very similar, just makes it a little bit more difficult. Again, we have x equals negative 2. We have x equals 1 minus 2i. I'm going to keep that in parentheses. And then we have our last one. Again, the complex conjugate of this is x equals quantity of 1 plus 2i. So again, complex conjugate. So this is also a 0 because they always come in pairs. And if you want to think why, if you look at the quadratic formula, if you plug in stuff, the way to think about the quadratic formula is you got negative b plus or minus the square root. If the square root is nice, you don't have anything square rooty, and you can actually figure out the plus or the minus thing. But if you have a square root that is not simplifiable, not a perfect square, or if it has imaginary, you're going to have both a positive and a negative thing of it, hence complex conjugate. That would be one way to think of it, or how you would get that. So now, remember we have x plus 2 is 0, x minus the quantity of 1 minus 2i, that's a 2, 2i is 0, and then x minus 1 plus 2i is 0. So now we put all of that together, or combine this again. So combining this, going backwards, is that we have our function f of x is going to be equal to this x plus 2 times this x minus 1 minus 2i, and then this x minus the 1 plus 2i, which is a very interesting looking thing. So again, choosing the right thing first is always the best option by putting these together. It will actually simplify out to be very nice. So f of x is going to be equal to, well, let's leave the x plus 2 alone, and let's distribute these. So this is a positive x squared. Now we're going to do x times that, which if we do that, I'm going to write it as negative 1 plus 2i times x, just kind of like we did in that example before, minus this 1 minus 2i and the x, and then we'll do plus, let me move this over for some room, and we're going to be multiplying a 1 minus 2i times a 1 plus 2i. Why did I make this a plus sign? Well, a negative and a negative make it positive, and then it's just this times this. And then we can simplify that all out. So going from here, we still have f of x is equal to x plus 2 times x squared. Well, what happens here is we have minus x minus 2ix, and then minus, let's see what that would be, x again, and then plus 2ix, and then plus 1, and then be minus 4i squared, which again, this is a positive 4. So if we multiply this times this, we get negative 4i squared, which is a positive 4. Remember, I squared is negative 1, just says turn this to the opposite. Now simplifying all of this is a chore, I know, but it is an interesting process. So we have x squared, those go away, we have minus this 2x because we're going to combine this, and then we'll combine those to be plus 5. And now we're basically there where we have to just distribute that out. So we're going to distribute x to all of those. So x goes to all of those. So we get x to the third minus 2x squared and plus 5x. We're going to distribute the 2 to all of those. So it's plus 2x squared minus 4x and plus 10. And then we combine our like terms, and then we are done, which again was a long process, but it is something I would like you to understand and know how to do. Notice how negative x squared and positive 2x squared, so both of those 2x and negative 2x squared will cancel out. We have this with this, which is just a positive x, and then we're left with just the plus 10. So all of that just to get here is our final answer. If you're willing to try one, please try it, pause it, I will have an answer shortly. After you tried it, I believe you should start with this, with its complex conjugate, so minus a negative 1 minus I, and this plus I. After you distribute just this part, you should get that this is this simplified. Then if you distribute this out and simplify it, you should get this.